Chapter 1.5, describe angle pair relationships. So the definition of complementary angles, that is going to be two angles that add to 90 degrees. Okay, it has to be two angles. And the definition of supplementary angles, it's going to be two angles that add to 180 degrees. Again, it has to be two angles. And finally, adjacent angles are going to be two angles that share a common vertex and a side, but have no common interior points. So I'll write that out. So adjacent angles, they share a vertex and a side, and they have no common interior points. So it would look something like this. And I could just do it with a straight angle here. If we made a straight angle, okay, and this would be the common vertex right here, and this would be the common side. Okay, so this angle right here is adjacent to that angle right there. Okay, it has to share the vertex and the side. So for the complementary angles, as long as they add to 90 degrees, two angles that add to 90 degrees, they're complementary. They can be adjacent or they can be non-adjacent. Okay, remember for adjacent, they share the vertex, which is right there, and the common side. Okay, non-adjacent, they're just two separate angles that are not sharing the vertex or the side. For the supplementary angles, same thing. As long as it's two angles that add to 180 degrees, they're supplementary. Okay, they can be adjacent like this. They share the vertex and the side, or they can be non-adjacent, not sharing a vertex or a side. All right, so we're looking at the figure at the right. They want us to name a pair of complementary, supplementary, and adjacent angles. Let's take a look. All right, so see if you can pick out a pair of complementary, supplementary, and adjacent, please. 3 letters per angle. Or in the case of this one here, you might be able to use 1 letter S. All right, complementary, they have to add to 90. All right, so I'll put the 90 in parentheses. And which two add to 90? Well, this one here is 32, and this one here is 58. 32 plus 58 is 90. So this one is CAB. Okay, angle CAB. And this one here is RST. Really, you can just say angle S because nothing is there, but I don't want to confuse people. So I'm going to write out RST, all right, because they add to 90 degrees. Supplementary, they have to add to 180. Okay, I'll put that in parentheses. And this one here is 122. Okay, and if we add that to 58, that's going to be 180. So CAD, angle CAD, and this one here is angle RST. All right, and finally, adjacent angles, they have to share the side and the vertex. All right, and you can see right here, this side here is shared by both angles, and the vertex is at point A. So that would just be this one here, which is BAC, angle BAC, and this one here is going to be angle DAC. Okay, let's look at guided practice number 2. They're asking, are KGH and LKG adjacent angles? Let's look at KGH and LKG. Okay, so KGH is this one right here, and LKG is this one right here. Are those adjacent angles? No. The vertex for one angle is here, and the vertex for the other angle is there. The vertex is not shared, so those are not adjacent. All right, let's look at FGK and FGH. All right, try these two and tell me if they are adjacent, please. Okay, FGK is this one right here. And FGH is, I'll do it in a different color. FGH is this one right here. So are those two angles adjacent? No. Okay, they do share the same vertex, but this side right here isn't shared by both angles. Okay, and also basically this angle is inside the whole thing. Okay, so that's not how it works. It would have to be a common or shared side. So this side right here would have to be shared by both angles if they were adjacent. It can't be one inside the other. All right, example 2a. Given that angle 1 is a complement of angle 2 and angle 1 is 68, find the measure of angle 2. So it said one angle is the complement of the other angle. Okay, so when they're complementary, what do they add to? 90 degrees. So see if you can find the measure of angle 2. All right, they're just going to add to 90. So if one of them is 68, then the measure of angle 2 is just going to be 90 minus 68. And that is 22, and that is in degrees. All right, given that angle 3 is a supplement of angle 4, and angle 4 is 56 degrees, find the measure of angle 3. Please try that one. All right, so if one angle is the supplement of the other, that means they're just going to add to 180. So if the first angle, or angle 4, is 56, the other one is just going to be 180 minus 56. Okay, so that is going to be 124 degrees. And that equals the measure of angle 3. Now, they did those problems in the book by drawing the angles, okay? These two add to 90, and these two add to 180, okay? But you didn't need to draw them because it said that they were complementary and supplementary. So we just subtracted one of them from 90 and the other one from 180. All right, when viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. So they add to 180. Find the measure of BCE and ECD. Let's take a look. Okay, so here's our drawing. Okay, if we go from B to C to E, that's going to be this angle right here. And the other one, if we go from E to C to D, that's just going to be this angle right here. Okay, they told us they're supplementary, plus we see they form a straight line. Okay, so these two angles represented by the algebra, 4x plus 8 and x plus 2, are going to equal 180. So please add the two angles together and set them equal to 180. All right, so I'll write the equation first. We have this angle here, BCE. So that's the measure of angle BCE. And then we're going to add the other angle, that's right here, ECD. the measure of angle ECD, and combined, they equal 180. All right, we said BCE was 4x plus 8. And we said ECD was x plus 2. And combined, they equal 180. Okay, like terms, these are all added. 4x plus x is 5x. And we have 8 plus 2 is 10. And together they equal 180. Okay, minus 10 on both. The 10s cancel. Bring down your 5x, and that's going to equal 170. Dividing both sides by 5. The 5s cancel. 170 over 5 is going to equal 34, and that equals x. Now, that's not quite what they asked. They wanted the actual measurements. So we have to plug in 34. All right, so putting the 34 right in here. That's going to be 4 times 34. I'll do this over here. It's going to be 4 times 34 plus 8. Okay, that's 120. 136 plus 8 is 144. And that's in degrees. And now the other one, plug in 34. And that's going to be 34 plus 6. And that equals, I'm sorry, plus 2, plus 2. 34 plus 2, and that equals 36. And that one's in degrees. Final check, 144 plus 36 is going to equal 180. So it checks out. Okay, let's try guided practice number 5. It says that angle LMN and PQR are complementary angles. Find the measures of the angles if one of them is 4x minus 2 and the other one is 9x plus 1. Okay, complementary means they add to 90. So these two angles are going to add to 90. So you add them up, set them equal to 90, solve for x, plug it in. All right, so let's write the equation first. This is angle LMN. So I'm going to write the measure of angle LMN. And I'm going to add that to the measure of angle PQR. Okay, combined, these add to 90 because it said they are complementary. All right. So LMN is 4x minus 2. And PQR is 9x plus 1. And combined, they equal 90. Okay, like terms, these are all added. 4x and 9x is 13x. Negative 2 and positive 1 is negative 1. And those just equal 90. All right, so we want numbers on one side, letters on the other. I have a -1 here, so I'm just going to do +1 on both sides. And 1 minus 1 cancels. Bring down my 13x. And 90 plus 1 is 91. Okay, dividing both sides by 13. Dividing both sides by 13. The 13s cancel. And 91 divided by 13 is 7. So x is 7. And they said they wanted the actual measurements. So we're going to have to take that 7 and plug it in. All right, if we put the 7 in here, that's going to be 4 times 7 minus 2. And 28 minus 2 is 26. And that's in degrees. All right, and if we put the 7 in here, that's going to be 9 times 7 plus 1. All right, 63 plus 1 is going to be 64. And that's in degrees. Okay, final check. We have 26 plus 64. We can just do that in our head. 26 plus 64 is 90. That is what we wanted because they said complementary. So it checks out. So the definition of a linear pair, it's basically two angles that are both adjacent and supplementary. So you can see here, angles 1 and 2 are a linear pair. Okay, they share the vertex right there. They share the side right here. And you can see together, they make a straight angle. So these two combined are going to be 180 degrees. So if you ever want to make a quick sketch of a linear pair, it's pretty simple. Just draw a straight line and then make a point approximately in the middle. That will be your common vertex. And then just draw a ray. And that will be your shared side. Okay, so now you have a linear pair right here with angles 1 and 2. And of course, because it's a straight line together, they add to 180 degrees. Okay, so right here is an example of two pairs of vertical angles. If I can give you a summation here for vertical angles, they make an X shape, and they must be straight lines. I should really say two straight lines. Let me fix that. Okay, they must be two straight lines, and the angles across from each other are vertical and congruent. So let's take a look. All right, here we have the X shape. Okay, and the angles across from each other are vertical and congruent. So here it says 3 and 6 are vertical. So angle 3 is congruent to angle 6. Okay, notice they are across from each other. They're not adjacent to each other. And then I'll mark it in a different color. Angles 4 and 5 are vertical. So angle 4, I'll mark it with 2 arcs, is congruent to angle 5. Okay, again, notice they are the ones across from each other, not the ones that are next to or adjacent to each other. So those are the vertical angles. You should get two pairs of vertical angles when you draw two straight lines that intersect each other. Okay, example 4, identify all linear pairs and all vertical angles in the figure at the right. Let's take a look. All right, so using this figure, see if you can pick out the linear pairs. You want to look for a straight line, two angles that form a straight angle, and the vertical angles, the ones that are across from each other in the X shape. All right, let's see for the linear pairs. If I can highlight a straight line, this line right here is a straight line. So we want two angles that make up that line. Okay, and we have angle 1 and angle 4. All right, together, those two make the straight line. That's a linear pair. So we have 1 and 4. All right, so that's going to be angle 1 and angle 4. All right, now if we go to the other side of this straight line, we have 3 angles. So that's no good. Now let's look at another straight line. How about this one right here? Okay, we have angles 4 and 5. When we put those together, they make the straight angle. So 4 and 5 are also going to be a linear pair. All right, so angle 4 and angle 5. Okay, and just like last time, if we go to the other side of that line, we have this right here. But that's no good because this is 1, 2, 3 angles, okay? It has to be a pair. It has to be only 2. Okay, finally, if we go to this line right here, it doesn't work because it stops. Okay, this right here is just a ray. So that's useless. So we have all the linear pairs. Now let's look for the X shape so we can do the vertical angles, okay? Remember, it has to be 2 straight lines. So let's see. Here's a straight line right here. And here's a straight line right here. Okay, so there's the X shape. So we want to do the ones across from each other. All right, let's see if we have 1, angle 1, and across from angle 1 is angle 5. Okay, so that's going to be angle 1 and angle 5. Now on the other side, we have angle 4, but across from angle 4 we have 2 and 3. So we can't say 4 and then 2 and 3. That's no good. Okay, it has to be a pair of angles that are across from each other. So that's no good either. You can't use 3 angles. So I think that's basically it for the verticals. Okay, we can't use this here because this is just a ray, not a line. So for the vertical angles, just like the linear pairs, okay, I'll put in parentheses that it must be a pair. Must be 2 angles. So that's it for all the vertical angles. There's just 1 pair of vertical angles. Okay, example 5, it says 2 angles form a linear pair. The measure of one angle is 5 times the measure of the other. Find the measure of each angle. All right, now since the 2 angles form a linear pair, okay, it's 2 angles, they're going to add to 180, okay, 180 degrees. And it says the measure of one angle is 5 times the measure of the other. So let x equal one angle. And if the other angle is 5 times as much, what would we use to represent the other angle? Well, that would just be 5 times x. So these are the two angles that we have, x and 5x. Now, since we said it was a linear pair and they add to 180, it's relatively easy to set up an equation. Okay, one angle is x, and when we add that to the other angle, 5x, they are just going to equal 180. Okay, x plus 5x is 6x. And then divide both sides by 6. The 6's cancel, and x equals 18 over 6 is 3, and then you add the 0, so x equals 30. Okay, if you want to find the other angle, you have to plug it in. All right, so 5x is just going to equal 5 times 30. And that is 150. Okay, now, do the two angles add to 180? Yes. Of course, 150 plus 30 equals 180. And that's what we said for a linear pair, so it checks out. So the answers are 150 and 30. Now, they drew a diagram for this problem, but you really didn't even need it, okay? They drew a linear pair here, but like I said, you didn't need it because we knew that the two angles added to 180. Okay, so let's see. Do any of the numbered angles in the diagram at the right form a linear pair? Which angles are vertical angles? Let's take a look. All right, first let's look for a linear pair. Okay, it has to be two angles based on the word pair. Okay, so let's see. If we drew a straight line right here, if we use this straight line, that's a little too much. Let me see. All right, if we drew a straight line right here, we have 1, 2, 3 on that side, no good. 1, 2, 3 on that side, no good. All right, so that won't work. Let's try another one of the lines. All right, let's see if we use this line here. 1, 2, 3, that's no good. 1, 2, 3, that's no good. Neither of those work. And then finally, this line here, we have 1, 2, 3, 1, 2, 3 on either side. So none of them form a linear pair. Okay. As far as the vertical angles, let's take a look. Let's look for the X shape. We need two straight lines. So if we do that there and that right there, look at the angles across from each other. We have 2 and 5. Okay, so 2 and 5 both work. I'm going to write angle 2 and angle 5. All right, now I'm going to erase one line and use a different line this time. So I'll erase this one and I'll use the other line this time. Okay, so this time I'm going to try this line here. All right, maybe I drew that too thick. Let me try it again. All right, I'll go like this. Okay, let's try this line right here. And across from each other on the X shape, we have 1 and 4. Okay, so 1 and 4 both work. All right, and now I'll keep the one I just drew, and I will erase the other one. Okay, and this new one, is going to be like so. So the ones across from each other, 6 and 3. So that is the final pair of vertical angles. We can't use these two and these two because it has to be a pair only. All right, so 6 and 3. 6 and 3 are going to be the last two. So that's it. Those were the 3 vertical angles. You can't use 2 and 2, okay? It has to be just a pair of angles. It has to be 1 and 1, and again, they have to be across from each other. All right, and as far as the linear pairs, there weren't any. Okay, please pause and try number 7 here. It says the measure of an angle is twice the measure of its complement. Find the measure of each angle. Okay, remember the complement, that is 2 angles that add to 90 degrees. So please try that one. Okay, so the measure of an angle is twice the measure of its complement. So we'll make one angle equal to x. Okay, and the other one is twice as much. So the other angle, if it's 2 times as much, it's going to be 2x. Okay, and since they are complements of each other, they add to 90 degrees. So setting up the equation is pretty simple. You just add the 2 angles and set them equal to 90 degrees. Okay, x plus 2x is 90. Three x equals 90, and dividing both sides by 3, x is 30. So that's one angle. The other angle is 2x. You want to plug in 30. So 2 times 30 is just 60. That's your other one. Okay, adding the 2 together just to double check at the end. $30 plus 60 equals 90. Okay, so it checks out. All right, so this last part, it's just about what you can conclude from a diagram. Okay, so just looking at this diagram here, you can assume that all points shown are coplanar. Okay, that just means they're in the same plane. Points A, B, and C are collinear, and B is between A and C. So you can assume that A, B, and C are all on the same line just by looking at it. All right, and AC, BD, and BE all intersect at point E. So, let me see. These all intersect at point B. Okay, let's see. AC, BD, and BE. AC, BD, and BE. Yes, they all meet at point B. So, in other words, you can assume that just by looking at the diagram. And these angles DBE and EBC are adjacent. DBE and EBC, you can assume those angles are adjacent. And ABC is a straight angle. So in other words, if it looks like a straight line, you can assume that it is a straight line, okay, just by looking at it. Okay, they're saying you cannot conclude that this is congruent to that, okay? Just because it looks like it, you can't say it is. It would have to have the markings on the diagram, okay? You cannot say this is a right angle unless it actually has the mark on the diagram, Okay, and finally, you cannot say these angles are congruent unless they have the marks on the diagram. So for stuff like congruence and right angles, it has to be marked. Okay, you can't just eyeball it and say it's congruent or a right angle.